you know about them? Yeah, so when you get x plus 3 equals 0, it's a double solution. Yeah, x equals negative 3 for both of them. So how many solutions do you have? 1. You expected 2, which technically you got, but it was a double solution, so you only write 1. Now the reason a perfect square trinomial only has 1, wait, it's a parabola. Parabolas go down and then they come back up. It crosses twice. How can you only have 1 solution? A perfect square parabola comes down, hits the x-axis, and turns back around. It bounces off the x-axis. Okay? So it's a parabola that doesn't actually cross the x-axis. Huh?
It's like a V?
No, it's still a parabola. It's not a V. A V comes from absolute value. It's still a parabola, but instead of coming down over the x-axis and then coming back up, it hits the x-axis, one x-intercept, and then turns around. And there are other parabolas which float, like this. And that one had imaginary solutions. We're going to get to that by the end of the semester. Okay. So that would have no solution, no real number solutions, but it does have imaginary solutions. But no x-intercepts. Okay.
For the one above, wouldn't we do like x equals 3, x equals negative 3, x equals negative 3?
Yes, exactly, yeah. So the solutions would be negative 3, positive 3, and negative 4. You write them each as the equation equal to 0, and that, yeah. So
change our sign.
yes. X, yeah, and be careful when you have coefficients. You also have to divide away the coefficient. But these are just real basic. So x plus 3 equals 0, x minus 3 equals 0, x plus 4 equals 0. Solves to make negative 3, positive 3, and negative 4.
Can you show us how that you would have to divide the coefficient? Or at least thank you.
Yeah, if you all it is if you had if you got down to factors like this. Oh, actually, no, we did that, didn't we?
I think so.
Yeah.
It was a 3.
Yeah,
Example 4.
Yeah. So we had a
Oh yeah, so the x.
right.
Okay, got it.
So we had negative 4 and negative 2/3 on this one. Yeah.
Yeah.
So whenever you have an a not equal to 1, you got coefficients, for example, on your binomial, you're going to end up with a fraction answer.
Okay.
Or if you have both of them have coefficients, you'll have 2 fraction answers. Okay? Your answers might be any real number. It doesn't matter if they're both positive, both negative, a mix, fractions, etc. Okay.
But the most important or the most careless mistakes that I think that I would make is not changing those signs, right?
Yeah. So that's exactly what homework is for, is to know. Everybody has, I make careless mistakes. Everybody has, but they're probably different from yours. Okay? So I show strategies for a lot of common careless mistakes and ones that I make personally. Homework is a time to develop strategies for ones, oh, I'm always missing this one. I'm always forgetting that. I'm always doing that. And you work on strategies to help avoid that. You've got to figure out what that's one of the things homework is not just to do the problems, but to develop your strategies. Yeah. Because everybody's has to be a little bit different because everybody's brains work differently. Okay, so quadratic application. You're going to see a couple of these on homework. Okay. And I'm going to do one, and we'll do one together, and then practice the ones on homework, and then you can get extra practice by finishing this. I'm going to post the solutions to this handout later. So consider this test practice. Okay? So a quadratic application, this is in a sense, actually let's look on the back page first. This really is not anything you haven't had before. It's just we've got exponents involved now. Okay? So you can X out these first 4. We're not getting to those. Okay? So we're just these last ones. So let's look specifically at number 5. Okay? This is back in the first chapter working with functions, but I primarily gave you linear functions in the first chapter. This is a function with all the same ideas, but it's a quadratic function in this case. Okay? So when you're given a problem about a function, remember a function has 2 variables, an x and a y, or in this case an x and an f of x. Or in this specific case, it called it c of x because it's standing for cost. It's going to have to tell you 2 things. The problem will tell you what your x is and what your value of your function is. So in this case, x and c of x. Okay? And it tells you. So you've got to read the problem and figure out, okay, this function, the c of x, the value of the function is about money. It's about cost. And x, okay, so this is a factory that makes these things. Yeah. So x is the number of units. Okay? So this is a real-world situation. You can have businesses, factories that have functions that they will model what they need to know, and they can know their historical information and make predictions for the future. This is relating how many units they can make versus how much it's going to cost them. So if they want to make a certain number of units, they plug that in for X, and they know how much it's going to cost them. If they know they have a certain amount of money they only can spend, they plug in that amount of money and figure out how many units they can make. Okay? So this relates to things, and that helps a business, a factory, in this case a manufacturing situation, function, so to speak. So here's the function that guides this particular factory. And so, well, now you've got to see what the question is, because questions like this will give you either your X or your C of X. You have to decide, what do I know and what's missing. You have to be given one thing, you have to plug it into the correct place, and then solve for the missing thing. Now, if you were given X, the number of units, you would just plug in X, and you wouldn't have to solve anything. You would just plug in your X's and simplify. Okay? But if you're given C of X, the cost, you have to put in how much money they have to spend here, and then you actually have to solve for X. Okay, so you have to know what your variables mean, and then which one you're given and which one is missing. So, given this function, which has these two variables, what is it given and what is it missing? So what information are we given? X or C of X?
C.
Right. We're given C of X. We're given that they have that much to spend, and here the question is, you always know what's missing in the question. Find the number of units. That means we don't know the number of units, so we don't know what X is. That's the unknown. So you're going to solve. You're going to plug in what you know where it belongs. C of X is 8,700. Okay. Yeah.
Are there any nodes that you can move?
Yes, and you have to move. Okay. Once you plug in what you know, treat this just like what we've already been doing. It follows the same set of rules. Kill any fractions or parentheses. Put it in standard form. Don't even think about factoring until it's in standard form and any like terms are cleaned up. Okay. Right, so we have to make this in standard form, so we have to subtract 8,700 from both sides. Right? Okay. So 6,300? It's negative though, right? So it'd be 2,400 over here minus 8,700. Yeah, so negative 6,300, right? So I'm also going to turn around because my eye likes to look at the quadratic on the left. So x squared minus 20x, and then plus 24, but minus 8,700 because I'm moving this over, so that gave me a negative 6,300. And because I minused 8,700 on both sides, then that's equal to 0.
Oh wait, I'm sorry, I missed that last part of the 0.
We want it equal to 0. So we have to do minus 8,700, so it's equal to 0. See, our other terms are over here. If you want to flip it around first to make it look, because basically I put the x squared minus 20x, and then plus, this is like doing that, like you said, the two steps in one. Okay? So I had plus 2,400, but I'm also doing minus 8,700 because I want to move it over from the other side. Now the other side's 0.
So you moved the 87 that way. You moved the 87 to the 2,400.
Yes.
But you could have done it the other way?
No. Okay, so I have 8,700 equals x squared minus 20x plus 2,400. Okay? Now, just because I don't want to move this x squared, it's positive. If I move it, I make it negative. Okay? So you want your quadratic term to be positive. So it's over here on the right, and my eye doesn't like to see it over there. So I want it to be on the left, but I don't want to make it negative. So basically, what I did here first is I just flipped the whole thing over. If this is equal to this, then I can write this. I'm not using my addition rule. I'm not changing any signs. I just flipped it over because my eye prefers to see my function on the left. Okay, and now I've got to do minus 8,700 on both sides. Oh, this was a plus, sorry. Yeah, plus. So I didn't change any signs. I just wrote this on the left and this on the right, just because my eye likes to look at it better that way. And now I do minus 8,700 on both sides. Yeah, and that's when you get this. Okay, so you get negative 6,300 on the side over here, and that becomes 0. Does that make sense? Does that clarify? Okay. And now I'm not going to move forward here, but obviously you factor it. It's an a equal 1 trinomial. Okay, factor it. Now, what are you going to have? 2 pluses, 2 minuses, or a mix? a mix. You're going to have one positive and one negative binomial. Okay? So that means if you have a mix here, you're going to have x plus something and x minus something, which means one of your solutions will be positive and one will be negative. And those will be, if you factor it correctly, those will be two correct solutions to the polynomial. But are they both solutions to the real world problem?
No.
You're solving for number of units. Can you have negative units?
No.
No. So in the real world problem, you throw out the negative answer. Yes, it's the correct math, but it's the wrong real world answer. So you're going to get one positive, one negative answer when you factor. You throw out the negative one because it doesn't make sense. They're not going to manufacture negative units. They'd lose money. It's not even possible. Okay. Make sense? Okay. All right, so I'll let you solve it there. Like I said, I'm gonna work these out as a solution page so you can treat this as test practice. You'll see a couple like this on the homework, and you can treat this as extra test practice. Expect one of these on the test. Okay? Okay. All right, the quadratic applications. This is a classic projectile problem. Projectile means something is thrown or dropped. And when something is thrown or dropped, it follows a parabolic path. Okay. Now, this is a pebble, and it's thrown upward from the top of this building. So somebody's on top of this building, and they throw a pebble up, and then it comes up, and it goes back down, and it hits the ground. And when they threw it at the starting speed, the initial velocity. Okay? And so the function that defines the path of this pebble is this. Now, you're not going to have to write this function yourself. It's given to you, but I want to point some things out because this is a very common type of problem, and you're going to see it moving forward, especially if you get into any physics classes. And even in college algebra, you may have to write this formula yourself. So when you're dealing in feet per second, conventional units, metric will be different, but feet per second is what your conventional units for doing these projectile problems. This right here will always be negative 16. Right?
Always?
If we're on Earth. Because the quadratic term stands for gravity. Okay? If you're on the moon or a different planet, this will be different. If it's metric units, it'll be different because metric is, different. Yeah. But if it's feet per second and you're on Earth, this will be negative 16. Now, the fact that it's negative means that it's an upside down parabola. A negative quadratic means it's an up because you're going up and then coming back down. A downward parabola. So the negative makes it a downward parabola. The negative 16 means this is gravity on Earth. That will never change. Now, this will change because this person threw this pebble at 96 feet per second. Your linear term is how fast the initial velocity was. Now, if the person just dropped it instead of throwing it, then there wouldn't be a middle term because the initial velocity would be 0. You're not throwing it, you're just dropping it. So you would just have a quadratic and a constant. Okay? And then the last term stands for how high were you off the ground when you started. Okay? So that's how this was constructed. Okay? And what it looks like visually looks like this. I'm going to draw a quadrant, but what happens here, this is right here, here's our building, okay? And here's the ground. Okay? And somebody stood on top of this building, and they threw this pebble up into the air, and it came back down, and it hit the ground. Okay? Now, our variables here are t and h of t. T and h of t. Instead of f and f of x. Okay? So our independent variable, our x, is actually t, standing for time. Remember, our independent variable, always goes on the horizontal axis. Okay? So our x-axis is actually the t-axis. This is how much time has passed. The origin is time 0, and so this is a second past, 2 seconds, 3 seconds, 4 seconds, 5 seconds. And every second that passes means that the pebble is at a different height. How high is it at 1 second? How high is it at 2 seconds? How high is it after 3 seconds? How high is it after 10 seconds? Okay? And so our y value, our value of the function, our y-axis is actually height. Or we can also write as h of t because height is a function of time. How high the pebble is depends on time. Okay? So our starting height is 880. Okay? Our starting time is 0, but after a certain amount of time passes, we have an end time. Here's the start time and here's the end time. It's thrown at time 0, and then it hits the ground at time whatever. Okay? And how high it is at each point of the way depends on how much time has passed. Okay? Make sense? Okay? So, there's two things you might be asked. You might be given a time and asked how high it is. In that case, for example here, h, what you know is the time, and what you don't know is the height. So the height is unknown. You have to write the h. Now instead of writing h of t, we can say h of 1 because that is the time we're using. So the value of the function at time equals 1 is equal to negative 16, always plug in parentheses, don't forget that, plus 96 times 1 plus 880. Now there's nothing to solve here because you just have to simplify. And once you simplify, you'll get a number that tells you how high the pebble is after 1 second had passed. Now, if you're instead asked, when does the pebble hit the ground? So this is when t is missing. I'm sorry, this is when h is missing. Okay? This is when the height is missing. Then you just plug in your t and simplify. Now when the time is missing, and we know the time is missing because it asks when. Okay? It doesn't know what time. Which means if you don't know what time, then what do you have to know? The height. Do you know the height? Are you told it?
Yeah, we do know the height.
Yeah, it doesn't give you the number, but it tells you it's when it hits the ground. What's the height when it hits the ground? 0. If you're asked when something hits the ground, you're being told that the height equals 0. Okay. Which means that you solve for height equals 0, h of t equals 0, so you have 0 equals negative 16 t squared, you're solving for t, plus 96t plus 880.
Then you factor.
Mm-hmm. Yes. Now, I wanted to walk you through a little bit more of this. I want to trust you to go from here. Let me just give you a couple of hints, but I want to give you more practice time, okay? So, okay, I've already gone a little late on that. What's going to happen here is, first I flip it over so it's this equal to 0. Easier for the eye to look at. But it's equal to 0, so you're ready to factor. Notice how there's a t here and a t here, but not one here, so you can take out a numerical factor. Now, this can get really messy with decimals and stuff. I'm not going to make it messy for you. You can trust that negative 16 will be a GCF for now. Not always in the real world, okay? But you can take out a negative 16 GCF. Make sure you're taking out the negative GCF, and that's going to flip your other signs. Now, because that's just a numerical GCF, is it going to give you a solution? No. If there's no t in it, negative 16, it is a factor, pull it out, but then you don't need it anymore. What you'll be left with is an a equal 1 trinomial. You'll be left with t squared minus 6t minus minus 55. Okay, when you do, I'm going to work all this out, so you'll try it and you can math. But it's going to leave you with an a equal 1 trinomial. So the negative 16 you don't need, you factored it out, but it doesn't have a variable. Then the a equal 1 trinomial that's left after factoring out the negative 16 will give you a plus and a minus binomial. And that will give you two solutions. And your solution knows time. Can you have negative time? No. That means you went backwards in time and through the building. It's a real math solution, but it's not a real world solution. So you'll get two answers as expected, but you throw out the negative one. Okay. Let's try those. Okay. So let's jump right into practicing with the time we have. And if you have any burning questions on this, then when we start practicing, feel free to ask me. Okay. And also, like I said, try these yourself in homework, and then on here, all the solutions will be available to you. Okay. And trust me that these are still using all the same steps you already know how to do in the same order. Okay. I'm not putting brand new things in the middle of this. It may look a little different, but just ask yourself, what's the next step? It will work. Okay. So what we're doing here is a domino. It's really just a way to practice some equations, but it's going to get you up and moving, work with partners, talk to each other, talk to me as you need. So I'm going to put 10 pieces, 10 dominoes around the room. Okay? And you're going to pick one. It doesn't matter where you start. Okay? You've got a recording sheet here. Don't do your work on the recording sheet. There's not enough room. Keep your notes with your working out the problems. Pick one, it doesn't matter where, and you start on the bottom. You start with the equation. The top has solutions and the bottom is equations. So pick some equation to start with. It doesn't matter where, which. Write down the equation on your sheet, go on your scratch paper, solve it, and write your solution here. Your solution is not the one on top here. Okay? This is not the solution to this. Okay? You solve this, you write down your solution, then you go around the room and you find your solution on the top of some other sheet. Okay? That's the domino effect. Now when you find your solution on some other sheet, write down whatever letter is next to your solution. There's a letter or symbol here. So find your solution, write down your letter, and then you do the next equation. The bottom gives you your next equation. find its solution, write down the letter, and do the one under it. You can start anywhere, but you have to follow the domino. Once you pick somewhere to start, you have to do the next one. These letters here, mostly, they will spell something, but this is not a word search. Okay? This is for me to see your sheet and be able to say, oh, okay, you're on the right track, or no, there's some letter off. It will spell something in the end, though not everybody's starting with the first letter, so it'll loop around, and once you figure out what it is, you can just write it out here in the correct order. Okay? Now, do as many as you can, work with each other. Like I said, don't worry about having to write all these down. I'm going to post these 10 problems with their solution page, so you can treat it as test practice as well, and check yourself later. Okay? These are going to be just randomly put around the room. Just make sure you don't carry it around, it doesn't get under a binder and get carried around, okay? Because everybody's going to move around. Okay. So, go ahead, anyone on this side, just go ahead and pick one, get started. There'll be 5 on each side of the room. Just make sure they're visible to everybody, because everybody's got to hunt for their answers. Okay? You can start with the one on your table or move somewhere else, doesn't matter. Take a pleasure. But once you pick where to start, that's going to be the domino. You have to go in that order then. Yes.
I've been trying to do number 15, but I kept saying that I have it wrong. I'm just confused on okay, I know I wrote down the y.
Okay.
But then this one I actually pulled it, but I spelled
Okay.
it.
All right, so you took out the y, 3x, negative 8x. That's fine. Good. Okay. So you pulled out the y, right?
Yeah.
So why are there y's left? See, that y is part of your final answer, but you're done with it for
Oh,
now.
I don't know why I put y.
Yeah.
That's where I went.
Oh, okay. So you've got your positive 15 and negative 8. Good. And those work. Make sure that's a plus, because you're multiplying on top, and that's adding there. Good. So you do have to split your middle. A is not 1, so you are not done. You split your middle, but your middle variable is just x.
Okay.
See, so even once you pull out a variable of GCF, you might even want to just cross out the original problem.
Yeah.
Because
I was pretty confused,
right.
but it was like the y.
Yeah, because then the grouping won't work. So you did put.
It's just I messed up on this.
Oh, I see. Okay. So you split that negative 8.
And I had written the white, and I erased it because I was like, wait, I don't know if I put in the
Ah, okay, yeah. So this should just be a 5, no y, right? And so you are factoring out a negative 1 there, because you have to do 2 negatives, yeah. So you see where it is.
Okay, so I should just cross out and then...
Yeah, and just make sure this is what you're working with now. That's part of your final answer, but you're done with it. You're just working with that now.
Oh, okay, thank you.
Uh-huh.
So, are we supposed to be just checking it? To see if the...
Well, you do the problem on the bottom, okay? That's on top. That is not the solution to that problem. Do the problem on the bottom. Yeah, on one of the other, yeah, like I said, these cards don't belong to any one person, they're just around the room. So make sure when you're using one, it doesn't get hidden, it doesn't belong to you, okay? So do whichever one you want to start with, the bottom equation. When you have the solution, that solution to what you're working on is going to be on a different card, top of a different card.
And I have to find out.
You have to find it, write down the letter that goes with your solution, and then do the equation that's on the bottom. It's like a domino, it's going to domino to the next one.
Right. Okay, right here. First, that would be GCF, right?
Jacob, Manuel,
Or 2X,
James, Lauren.
Is this where you're at?
Oh, yes. Yeah, make sure if you want to, they can go get that in the back. Just remind me to, yeah. Veronica? Yes.
Oh, the green.
So you're just.
Oh, 4, right?
Oh yeah, it is.
This first one's always quiet, but then once you go looking for your first solution, like I said, feel free to talk, work together, ask any questions. Don't forget to get your practice review on the way out, or now or on the way out. Don't forget to take that when you leave, before you leave. Are you leaving?
No.
Okay.
No. It's doing-
Packing up for a long trip?